All right, everyone. Yesterday we talked about two-dimensional figures, and today we're going to look at some three-dimensional or 3D figures. And just like yesterday when we were doing two-dimensional figures, we focused on area and perimeter. Today we're going to focus on what's called volume and surface area. So let's talk about the difference between those two things. A three-dimensional figure has space inside of it. That's volume. Volume is how much space is actually inside the shape. Now, surface area is like area from yesterday, but it's the area of all the different sides of the shape added up. So for example, let's say just a box. An ordinary cardboard box, you order something from Amazon, you get home, there's a box on your porch. The volume is the amount of material that's inside the box, the amount of space inside of it. The surface area is the amount of material used to make the box. So that's a good example of like word problem versions. If you're talking about the amount of space inside a box, that's a volume question. If you're talking about the amount of material used to make a box, that's a surface area question. All right, so I'm going to focus on two different three-dimensional shapes. There's a lot more, but just since this is an introduction, we're going to focus on two today. The first one's a prism. And a prism is a three-dimensional shape where you have two congruent and parallel bases. And those can be any shape. You can have triangles, rectangles, other things. I'll show you a picture of some in just a second. But they are congruent, they're the same, and they're parallel, like one above the other. And then they're connected by perfectly flat faces that are usually rectangles. Now, the most simple type is what's called a rectangular prism. When I put a word in front of prism like that, it's telling you the shape of the base. So a rectangular prism is a prism where the base is a rectangle. And that's basically a box, like I just told you about in the last slide. You know, a box from Amazon is a rectangular prism. So let me show you a few. I'm going to take me out of here. Right here, here's several different prisms. The first one we call a triangular prism because you can see that the bases right here are these triangles. Those are the congruent parallel shapes, and then they're connected by sides, by faces. The second one is a rectangular prism because it's got a rectangle on top and a rectangle on bottom. And then remember that that's basically a box. A cube is like a rectangular prism, but it's a square instead of a rectangle. Instead of calling it a square prism, we call it a cube. We have a different name for that one. And then on the bottom, you see a couple more complex ones. A pentagon has 5 sides. This is a pentagon right here, 1, 2, 3, 4, 5. So that would be called a pentagonal prism. This one over here, a hexagon, has 6 sides. 1, 2, 3, 4, 5, 6. And then again, you can see on both of these shapes, the base is the same. So a prism can have any base. All the shapes you're looking at right now are types of prisms. There are a lot of different ones. Okay. So first thing we'll do is volume. Volume of a prism, where it looks like a very simple formula. Volume equals B times H. Now the problem is capital B stands for the area of the base. And depending on what the shape is, that's a completely different question. If the base is a triangle, we use 1/2 base times height, like we did last section. If the base is a rectangle, we use length times width. If the base is a hexagon or a pentagon, it becomes a much more complex question. So depending on what the base is, this right here is going to be different in each problem. Capital B means the area of the base, but then you just multiply it by the height, which is the distance between the two bases. Now, we don't have a formula for surface area, not a specific one anyways. What we're going to do is we're just going to imagine taking this shape and flattening it out, finding the area of each side separately, and just add it all up. So kind of like perimeter was just add all the sides up, this is add all the areas up. So let's do our first example. We have a triangular prism. I can tell because I can see the triangles. Right here in front, here's a triangle. And then right here in back is a congruent triangle. So this is kind of like a prism tipped over on its side. Usually when I say the word base, you think bottom. So like the base is the bottom and the top. This is one that's been tipped over on its side. So the base is actually the front and the back. But that's okay. We can still work with that. So the first thing I want to do is find capital B. I want to find the area of that base. That's the red triangles that I highlighted. So I say, okay, well, we learned last section, area of a triangle is 1/2 base times height. And for the base and the height, what's nice is this is a right triangle. And on a right triangle, it makes finding the height easier. Sometimes the height is hard to find in a triangle, but when you have a right triangle, as long as you take the two right angle sides, one of them is base and one of them is height. So if I think of the base as basically the bottom, the 24, right here, then the height of that triangle is 7. It's just the other side. So the area of that would be 1/2 times 24 is 12 times 7 is 84. So the area is 84, and now I can use that to find the volume. So this is kind of like a separate question here. Volume is capital BH. And this is a different H. That's a little bit tricky. The H I used in the first one, base times height, was the height of the triangle. The H I'm using right now is the height of the prism. It's actually going to be 22. So for volume, what I get, capital B is 84. We just figured that out. Times the height. Now remember, the height is the distance between the two bases. So if you look from the front to the back, from triangle to triangle, the distance between those two bases is 22. So volume is going to end up being 84 times 22. I'm going to pause this and find a calculator real quick. Okay, our volume ends up being 1,842. Now let me just talk about units for a second. If you look at the picture, we're measuring everything in meters. M stands for meters. Now when you're doing volume, because it has space to it, you use those same units, but it's not meters, it's cubic meters, because it has to have space. So like you're saying a cube with 1 meter on each side, how many of those would fill up this shape is really what you're saying. So answer for volume is 1,842 cubic meters. All right, let's do surface area. Now for surface area, what I have to do is add up all the sides. Now 2 of the sides are those triangles, and we already found its area. They're 84. So I'm going to start with 84 plus 84. That gives me the 2 bases, the front and the back. Now, there are 3 more sides to this, and they're all rectangles. I have that top kind of sloped side, I have the bottom flat side, and then I have the back. Let's do the top first. For the top, for all of these actually, since they're rectangles, the area is going to be length times width. So for the top, if you look at it, the 2 components of that rectangle are the 22 on the right side and the 25 on that kind of angled side there. So 22 times 25 would be, we'll go back to the calculator, that would be 550. Okay, now let's do the bottom rectangle. Now that bottom rectangle, if you look at its sides, that would be a 22 again. This time it's 22 times 24. If that bottom rectangle, one of the sides is 22 and one is 24. And if I multiply 22 times 24, I get 528. All right, the last one would be the back, the smallest rectangle, the one that's kind of on the back side there. Now, if you look at that rectangle, oops, it's not an equals, that should be a plus over here. Let's fix that. Plus. The back rectangle is 7 by 22. So this time I'm going to do 22 times 7, and that would be 154. So for my final answer for surface area, what I need to do is add all those numbers up. I have 5 different sides, 5 different faces. We have the 2 bases and then 3 different faces. And 2 of them were triangles, they were both 84. 3 of them were rectangles, I did length times width and I got those 3 numbers. Let's add it all together. It looks like it's 1,400. Now for units again, I'm going to do something similar but not the same as volume. I'm going to say I was measuring in meters in this question. But this is area. Surface area is a type of area, and we said yesterday, area is measured in units squared. So this is going to be in square meters. So that's a good thing for you to remember. No matter what the shape, surface area is measured in square units, and volume is measured in cubic units. All right, let me talk to you about one more shape. I said we're going to do 2 today. We did the prism. The other one I want to talk to you about is a cylinder. And a cylinder is just like a prism, but it has a circle for a base. So you almost could call a cylinder a circular prism. That's kind of what's happening. It's a prism with a circle for a base. But technically it's not a prism. Prisms have to have straight edges everywhere. No round edges, no circles. So it's can-shaped. A cylinder would be like a soup can at the grocery store, or a soda can, or something like that. Now what's good about it is we know the base is a circle. It's not like sometimes it's a triangle and we do this, sometimes it's a rectangle and we do that. The base is a circle. It's the same every time. And that means there's only 2 components. You have the height, which is the same as the height from the prism. It's the distance between the 2 bases. And then you have the radius of the circle. And if you know h and you know r, that's all you need to know. So let's do this. Let's take our prism formulas, apply them to this, and come up with new formulas for a cylinder. So we said the formula for volume of any prism is capital B times H. And we also said a cylinder is basically like a prism, but it has a circle for a base. So what I can do is I can say area of the base, this capital B right here. Well, if I know the base is a circle, then I know that area is going to be pi r squared. That's area of a circle. So if I substitute that, you get a formula for volume of a cylinder. It's just pi r squared h. So volume of a square, or for a cylinder, volume of a cylinder, we don't need to say like, well, let's let capital B as the base, and sometimes I do this, and sometimes I do that. Capital B is always pi r squared h, because the base is a circle. So instead of doing it the long way and doing it in 2 steps, you can think of this as a formula for volume, pi r squared h. Now let's do the same thing for surface area. To do surface area, we have to imagine cutting up the can like this picture here. And I'll take me out so you can see it. So we started with a can. Imagine this is like a soup can. And we do a can opener around the top, we cut the top off, we cut the bottom off, we fold it up, and then you take a scissors and you make a cut straight up the can and flatten it out. You have a rectangle. So what you can do now is if you find the area of those 3 pieces, it's 2 circles and 1 big rectangle. If you find the area of those 3 pieces and add it up, you get the surface area of the can. All right, so number 1, every circle, if we're doing area, is pi r squared. So this is pi r squared here, and this is pi r squared here. That was easy. Now let's figure out that rectangle. We know the area of a rectangle is length times width, and in this picture, the length, or one of the sides, is the height of the cylinder. So remember, this right here, h, is the height of the cylinder. That's going to be the same as the height right here. That's going to be h also. So whatever the original height of the cylinder was, h, becomes either the length or the width of the rectangle. So the only other thing you need is the other component for that rectangle. Now if you think about it, the width of the circle right here is the circumference, the width of the rectangle is the circumference of the circle. Because remember, if you folded that around and made it back into a can, that goes all the way around the circle once. Those 2 lengths have to match up. So what we have is 2 pi r. That was our formula for circumference of a circle. So when I go to find each piece, I say, okay, well I have pi r squared plus pi r squared for the two circles. That would be 2 pi r squared. That's this part right here. Then I have to add it to the rectangle. That would be length times width. And that's where the 2 pi r squared h comes from. So what you're saying is 2 circles plus 1 rectangle. The 2 circles is 2 pi r squared. The rectangles is 2 pi r times h, length times width. Now you have a formula for surface area. Now if you remember the formulas, then you don't need to go through this process again. I just wanted to show you where the formulas came from. So let's wrap it up with one last example. Let's find the volume and the surface area of this cylinder. And when you look at the cylinder, you notice I gave you exactly what you need. The height is 12, and the radius is 6. Those are the only two things you need. So let's use our formulas. Volume equals pi r squared h. See, I'm not going to do B, capital B times h and plug in a formula. I'm not going to do it in 2 steps. I'm just going to use the one formula. So volume is pi times, let's see, the radius is 6 squared times the height, which is 12. Now what you can do is just reach for a calculator and do that. Remember, our calculators have a pi button on them. Use the pi button. Don't type 3.14. You'll be off by a little bit if you do that. But let me pause and do the calculator work, and I'll come back to the answer. Okay, I got about, I'll round it off, I got about 1,357.2. Now for units, remember this is volume, so I look back at the question, we're measuring in centimeters, but it's not centimeters, it's volume, so it's cubic centimeters. All right, now let's do surface area. Surface area is 2 pi r squared h plus 2 pi, sorry, I said h on the first one. It's 2 pi r squared plus 2 pi r h. And let's plug those same numbers in. So we have 2 pi times the radius was 6 squared plus 2 pi times 6 times 12. Now again, we can use a calculator here. Type it all into a calculator, crank it out, see what it comes out to. I'm going to pause again and come back with the answer. Okay, the answer I got for that one was about 678.6. And we're measuring in centimeters again. This was surface area, so it'll be square centimeters. So once you know the formulas, a cylinder is actually easier to work with than a prism because you don't have to worry about what the base is. You don't have to do one thing for a triangle, one thing for a square, one thing for a rectangle. It's the same formula each time. As long as you know the formulas, you plug the numbers in, you can let a calculator do the work for you.